Well, welcome back, and now let's do a couple problems and see how we can apply what we talked about in the last one when I introduced the definite integral. Now let's think about integration and displacement. Let's see how this works. All right. Now let's say if my velocity, or if you can think about your velocity, walking down a hall can be illustrated using the sine of x function. All right. And we're going to go from 0 to 2 pi. So what I did was I graphed this, all right, sine of x function here. And so what we're going to do is we're going to start at 0. And we're walking down, all right, this is our velocity. So we're going up here, and this is going to be pi over 2 right there. Okay. And right here at pi over 2, I can see that my velocity is going to be 1. But then all of a sudden, I start going right here, and my velocity starts speeding up, and then it starts slowing down. This is at pi. Well, right here, if you think about it, I'm going in a positive. I'm going to the right because the velocity on this interval, right, is greater than 0. Well, now all of a sudden, I realized something, and maybe I forgot it. And so I decided to go back. And when I go back, I start speeding up. I get back to here. Once again, this is going to be 3 pi over 2, all right, at this point. And then I get to back to where I started, which is going to be 2 pi, all right, because I went back. So because the velocity is less than 0, I'm moving back to the left, all right, or back towards where we have. So right here, this is going to be, all right, moving away or to the right, okay, from the object or away, and then I'm coming back. Now, let's think about this, and let's see what's happening from here. So I kind of explained it, but let's kind of think about this. Explain what is happening from 0 to pi. Well, from 0 to pi, as I stated before, from 0 to pi, we are moving, all right, because our velocity is positive, we're moving away or to the right of the object, okay? We're moving away, okay, from where we originally started, which was right here at 0, 0, okay? Or we're assuming 0, 0. That's what's happening. So then what happens right here, when we go to starting at pi, because the velocity is negative, we're moving left or toward, all right, the initial position right there. So now the question is, just kind of think about this. If I asked for my total displacement from 0 to 2 pi, what would that be? Well, my displacement is, all right, where am I in regards to the original position? Well, taking this, I can see that I started going away, and then I came back, and it appears my displacement from 0 to pi, or 2 pi, is 0. Now, to kind of illustrate this, we can use integration to help us figure out what our distance we traveled in each one of these cases would be. And this we're going to do is we're going to use our calculator. So if I want to figure out what was the displacement that I traveled, all right, from 0 to pi, this is how I would set it up. I would take the integral, all right, the definite integral of 0 to pi of my velocity function, which is sine of x dx. All right, actually sine of t, I guess it would be. I should change it up. All right, sine of t. All right, sine of t dt. All right, and that would give me my displacement. So if you want to do this, all right, and what we're going to do is I can take out my calculator. So I'm going to put in the sine functions, sine of x in here. All right, and if you go to graph, I'm going to show you a little trick if you didn't know about this. Oh no. All right, well, we have this, it's kind of level out. So here is my sine function. We'll go zoom 6, get something better here. All right, so you can see going up and down, up and down. So here we go, and we're going from 0 to pi. So if you go to second calculate, right here, you notice on your TI, you have this little button right here, which is the 7. You press that, and now what we're going to do is integrating, where our lower limit from 0, all right, press enter, and then our upper limit, which is pi, so pi is located right there, all right, pi, press enter, and what will happen is actually your calculator will actually solve the definite integral for you. So what is it going to equal? This is going to equal 2. So from 0 to pi, our value is going to be 2. Now, the next part is, let's figure out what is happening here. Well, from what we just stated, we're going to the left because our velocity is negative. Well, thinking about what we have here, if I took the integral from pi to 2 pi, knowing that we find displacement, what can you guess that the velocity, or sorry, displacement would be? Well, I'm thinking that this probably should be negative 2 because we're coming back. So let's look at this and let's try this again. All right, I'm going to go here. I'm going to go second calculate. I'm going to go down to 7 because I'm going to find the integral. Look at that cool thing. all right, 7. And now I'm going to go from pi, that's my first one, and then I'm going to go to 2 pi, so 2 pi, right there, and I press enter. And now it finds the bottom, -2. Exactly what we thought. Because it's below the x-axis, this is going to be -2 units. And this right here will be 2 units. So then what is our total displacement from 0 to 2 pi? Well, if I add this area plus this area, which is negative, our displacement should be 0. And you can put that in your calculator and figure that out as well. That makes sense? So essentially, when we find a integral, all right, a definite integral, just like any Riemann sums, we're finding area underneath the curve. Areas underneath the curve. Well, let's try some other ones. All right. Well, using our calculator, all right, we're going to use a sine function. Now let's see if we can figure out some other ones. Let's see if we can find out if we have, for example, 0 to sine. We know this is going to equal 2. All right, that's equal 2. All right, because we found it on our last slide. What would the value be if you went from -pi to pi? Well, -pi we know is starting over here, and it's going to be below. All right, so -pi, and we're going to pi, which is right here. Well, once again, we're adding this, all right, which is below the x-axis, so it should be -2, plus this one, which is above the x-axis, which is 2, we should equal 0. Now, if you're not sure, let's just go to the calculator and just kind of figure this out. All right, let's go into sine function. Let's go second calculate. Let's go to 7. And just to verify, all right, oops, let's do that again. Second calculate. All right, 7. All right, we're going to go from -pi. Make sure you put the negative. Second, right there, press enter. And then we're going to go to pi, right there. And let's see what happens. Right here, 0. Awesome. And that is what we get. Now, if you go from here, okay, let's say we start at 0. All right, going to pi over 2. Well, what happens to this object? What do you think the area is going to be? Well, if you're thinking that, well, I'm splitting this up in half, you're right, because there is symmetry. So our answer would be 2 divided by 2, which would equal 1. And that would be the area underneath that curve and displacement as well. If you did this, another thing is, if we took 2 sine of x, well, what's happening from 0 to pi? Well, what is happening when we have the 2 here? Well, we're essentially making this twice as big, right? Twice as big. So what are we going to do with the area? Well, our area is going to be twice as big because our new graph is going to go, instead of being at 1, it's going to be up 2 and come down. Oops, that's not horrible drawing. But we're going to have a twice as big of an area. All right, so guess what our value is going to be? Well, from 0 to pi we know is going to be 1. We figured another one. If we take the 2 times the 1, we'll have an area of 2. Here we go. Let's check out another one. Let's say I have 2 plus sine of x. So what happens when I have 2 plus sine of x? I'm going to clear this out right here. All right, delete that. All right, if I have from 0 to pi of 2 plus sine of x, well, what happens when you have 2 plus sine of x? Well, what we do is we move everything up 2. So right here, this is moving up like this. And now we have our graph like so. But now it's shifted up. Well, guess what we need to do? We're going to be taking our area from 0 to pi, which we know this part. All right, so we're just taking this part. This part up here, we're doing a little geometry, is 1. And we're going to add it to, guess what? Because we shifted it up, we created a rectangle. And so now we need to figure out the area of that rectangle. Well, from here to here, all right, oops, I went the wrong way. From 0 to pi, right? 0 to pi. All right, 0 to pi. And the other one is messed up too. I'm sorry. This isn't 1, it should be 2. Everybody at home is going, oh my goodness, what is this guy? Why am I even watching this, man? All right, this can't be 4. So if you thought it was 4, I apologize if you're taking notes. It is 4. 0 to pi, we're actually doing all of this. I'm sorry, I'm so sorry. All right, 0 to pi, which is actually going to equal 2. And now we're finding all this area. I apologize. So what is from here to here? That should be pi times its height, which is 2. So we have 2 plus 2 pi is going to be the area underneath that curve. So what did we just go through and what did we just figure out? How to find areas and how to find definite integrals by finding the area, all right, and displacement underneath the curve. Above the curve, we know it's positive, and below the curve, we find what's negative. I hope this helps you out on doing some additional problems. We're going to have some more tutorials on how to do definite integrals in just a little bit.